Good morning students. In the last class we have seen our concyclic points and power of a point, and moreover one example we have done. Now we are going to do some more examples now. The first example, if the point 2, 0, 0, 1, 4, 5 and 0 C are concyclic, then find the value of C. Here say 4 points given and concyclic. I said whenever you get like this, here first we will find out equation of circle passing through these 3 points. Then we will check whether fourth point satisfying that equation or not. That means our equation of circle is satisfying by the fourth point or not. If satisfies, then we can say that they are concyclic. So to do this kind of things, we will go ahead in algebraic approach. Means we take our equation of the required circle as x square plus y square plus 2gx plus 2fy plus c. So I will take equation of the circle which is passing through these 3 points as x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay, like this I am taking. Now, since circle passing through this, so 2 0 must satisfy this, means I am substituting 2, 0 in place of x 2 y 0. Then you will get 4 plus 0 plus 4g plus 0 plus c is equal to 0. So one relation we got. Next we will substitute 0, 1, then another relation can be obtained. On putting 0, 1, here x has 0, y has 1, 1 plus 0 and 2f plus c is equal to 0. Similarly, the third point we will put. Third point, here 4, 5, if I substitute 4, 5, 16 plus 25 plus 4 to the 8g plus 2 5 is 10f plus c is equal to 0. So we got 3 relations, then we will try to find out our G of C from these 3 relations. See, if I call it as 1, it has 2, it has 3, then just by subtracting 2 from 1, okay, here see CC cancel, 4 minus 1 3, that means 2 minus 1 I am writing, it implies 4 minus 1 3 plus 4g minus 2f, 4g minus 2f, 2f c gets cancelled is equal to 0. This is one relation we got. Now we will go ahead with second and third then. Second and third, if I subtract 1 from other, cc cancel here, then here 25 and then 16, 41, okay, 41 minus 1 I am writing 3 minus 2, 3 minus 2, it implies 3 minus 2, it is 41 minus 1, 40 plus here 8g minus here g term is not there, so 8g plus 10f minus 2f, 8f plus cc cancel is equal to 0. So another relation has come. Then here see, throughout this 8 we can take common, so 5 plus, okay, g plus f is equal to 0. Now we will solve these two to get g and f. Here see, if I multiply this equation by 2 and then adding this with this, minus 2f plus 2f cancel. So I am adding these two, okay, after multiplying this by 2, then on multiplying this by 2, 2 5s are 10, 10 plus 3, 13 you will get, 13 plus, here we multiplied this by 2, 2g plus 4g, 6g will come, 6g is equal to 0, because f terms have been cancelled. Okay, so we got g as minus 13 upon 6, z. Similarly, here I will try to, here g we got, then if I put here f will come, so f is equal to from this minus z minus 5, minus z means 13 by 6, okay, minus 5 will get, in this way 13 by 6 minus 5, then 13 minus 30, okay, that is minus 17 by 6 we got, this is f value, 13 minus 30, minus 17 by 6, these are g and f. If I substitute g and f either in this or in this, C we can find. We got g as minus 13 by 6. If I substitute here, 4 plus g, that is 4 into g. 4 into g means 4 into minus 13 by 6. 2 and 3 times cancel, 2 will be left. So in the numerator 26 upon 3 will be there, plus c is equal to 0. g I am keeping here, 4 into 13 by 6. 2 from this cancel, 2 into 13 minus 26 by 3 will be left. So 4 3s are 12, 12 minus 26, so minus 14 by 3 plus c is equal to 0. So what is c value? 14 by 3. C we got as 14 by 3. C is equal to 14 by 3. So, we got G, F, C. If I substitute all these in the equation, then we get equation of the circle. That is, equation of circle is x square plus y square plus 2gx. G we got as minus 13 by 6. 2 times of this, in 2 into minus 13 by 6 means 2 cancel, then 13 by 3 you will get. So, minus of 13 by 3 into x, and then 2f, that is minus 17 by 6 into 2, again 2 cancel over here, minus 17 by 3 into y, okay, plus C we got as 14 by 3. This is our equation of the circle. Now, to find out C value, here since all these points are concyclic, 0 comma C must satisfy this. So, we will substitute 0 comma C over here. If I substitute 0 comma C here x has 0, y has C, it is C square minus x 0 means this is 0, and then minus 17 by 3 into C plus 14 by 3 is equal to 0. Now, on taking LCM, C square minus 17 by 3 into C plus 14 by 3 means 3 is LCM. So, you will get 3C square minus 17C plus 14 is equal to 0. Then C values we can find out. Here see 14 3s are 14 into 3 and then 14 plus 3. So, it is 3C square minus 3C minus 14C plus 14 is equal to 0. Then 3C if I take common, C minus 1 minus 14 common, C minus 1 is equal to 0. So, C minus 1 into 3C minus 14 is equal to 0. So, C is equal to 1 or 14 by 3. These are the values of C we got. But when C is equal to 1, this is 0 comma 1 you will get. That is one of the given point. That is why you do not take C is equal to 1. So, required value of C is 14 by 3. Therefore, C value is 14 by 3. In this way, we can do it. We will do another problem. That is two rods of lengths A and B sliding on coordinate axis such that their ends are concyclic. Then is asking locus of center of the circle. Say rods are sliding on coordinate axis. So, the lengths given as A and B. Okay, such that their ends are concyclic. Suppose if I take x axis, y axis. Now, for the sake of convenience, I am taking our rods along x axis and y axis. That is already said. I am taking like this here. See, suppose A is this and B is this. AB is this rod. Its length is A. Now, CD is this rod. Here I will take CD like this. CD is this rod. The length is B. This length is A. This length is A, and this length is B. Okay, it is A and it is B. Now, he is saying that the rods are sliding on the axis such that these 4 points A, B, C, D are concyclic. Here, if I join, you will get a circle like this. Then, locus of center of the circle is asking. So, if I assume that it is the center of the circle is here. Now, that center has some x1 comma y1 because it is asking locus no x1 comma y1. Now, here see, from this center, if I draw a perpendicular to this x axis, we know it bisect. Now, here see, it is origin. Then observe by intersecting chords theorem, AB is one chord, CD is another chord. They are intersecting at origin. So, product of their segments equal, that is OA into OB is equal to OC into OD we have. So, we use that here. That means, OA into OB is equal to OC into OD I am using. OA means this whole length. Here see, since this length is A, so this perpendicular bisect, then this length will be A by 2. This part will be A by 2. This part is A by 2. This is A by 2. This is also A by 2. This is also A by 2. Now, we required OA. This means this whole length is required. But as far as coordinates, this length is x1. Distance of the point from y axis is x1. So, it is x1, it is x1, it is x1, it is A by 2. So, what is OA length? A by 2 plus x1. So, we can write OA as A by 2 plus x1. Next, OB length. This is OB. No? Here see, we know from here to here A by 2. Why? Because this bisect, no? This point bisect. So, this is A by 2. Now, we required this OB. A by 2 minus x1 if I write. Why? Because it is already x1 we know. x1, A by 2 is all this length minus x1 if I write. OB you get. That is why OB can be written as A by 2 minus x1. This is equal to OC now. Here see, again the same way, if I draw a perpendicular from this point to this chord, it will bisect. That means this part is b by 2, this part is b by 2 and this part is also b by 2. Then here see, OC length, this is OC, this is b by 2 and this one is y coordinate, this length and this length both will be same. So, distance of the point from x axis y coordinate, it is y1, it is y1, it is b by 2. So, OC is b by 2 plus y1. So, we can write it as b by 2 plus y1 OC value. Am I clear? And then OD value, OD is this. See, this whole is b by 2, this whole is b by 2, then this is y1. So, this length can be written as b by 2 minus this y1. So, OD can be written as b by 2 minus y1. In this way, when these 4 points A, B, C, D are concyclic, we are using intersecting chords theorem, OA into OB is equal to OC into OD like this. Now, if I multiply A plus B into A minus B, A square, that is A square by 4 minus x1 square is equal to B square by 4 minus y1 square we can write. So, from this we can write x1 square minus y1 square is equal to A square minus B square by 4 you will get. So, on cross multiplying and replacing x1 y1 by x and y, why? Because it is for all positions of locus no. So, for all positions, so 4 into x square minus y square is equal to a square minus b square. This is our locus of center of the circle when these ends of the rods are concyclic. Next problem, here see, if two lines 2x plus 3y minus 1 is equal to 0, kx plus 4y minus 5 is equal to 0, meet axis in 4 concyclic point, then find value of k and hence equation of the circle. See, in concyclic points, I told you any two lines meet the coordinate axis in 4 concyclic points, we have m1 into m2 is equal to 1. So, that condition we use. Thereafter is asking equation of the circle. I told you how to get equation of the circle. Just by multiplying these two equations and then subtracting xy term, you can find out the equation of the circle. So, first time here equations of lines are these 2x plus 3y minus 1 is equal to 0, first line. Here what is the slope of this line? m1 is equal to minus a upon b, that is minus 2 by 3. Similarly, second line is kx plus 4y minus 5 is equal to 0. Its slope m2 will be m2 is equal to minus k upon 4. Now, if they are concyclic, we have m1 into m2 is equal to 1 for concyclic, then minus 2 by 3 into minus k by 4 is equal to 1. Here minus minus you will get plus, then here 2 in this 2 times cancel. So, you will get k by 3 into 2, here 2 this 2 times cancel, k upon 6, that is equal to 1. So, k value is 6. So, if they meet the coordinate axis in 4 concyclic points, we got k as 6. Then is asking equation of the circle, passing through those 4 points. So, to find out that, here see, equation of circle, equation of required circle is now just what I said, we multiply these two equations, that means 2x plus 3y minus 1 into this equation on replacing k by 6, 6x plus 4y minus 5. This is our equation of pair of lines and it satisfies a is equal to b. See, 12x square, 12y square, a is equal to b, but xy term is involved, that we have to remove to get equation of the circle. No? So, what is xy term? That I will write. Here see, x multiply with y, 4 2s are 8xy and this x multiply with y, 6 3s are 18y. So, 8xy plus 18xy, that is 26xy term is involved here, that I am subtracting. 26xy is equal to 0. This is our equation of the circle. Means if you expand this, just here see 12x square plus 3 4s are 12y square and then here 26xy cancel. Then x term 2 into minus 5 minus 10x minus 6x minus 16x and y terms minus 15y minus 4y minus 19y and plus 5 is equal to 0. See, this is our equation of circle and dividing by 12, x square plus y square minus 16 by 12x minus 19 by 12y plus 5 by 12 is equal to 0. In this way, we can find out equation of circle passing through 4 concyclic points. Now, we will see next subtopic, that is our tangents and normals. Here see, before go to the tangent, first I think you know about secant. Any line, secant line, any line meet the circle at 2 points, that is called secant line. That means here suppose circle is there like this, a line is like this, it meets the circle at 2 points, then it is called secant line. Okay. Now, if a line meet the circle at 1 point, that is nothing but here see a line touches the circle, here see like this, meet the circle at 1 point, then it is called tangent. Okay. That means tangent always meet the circle at 1 point. Now, to find out equation of tangent, here we will proceed like this. Suppose a point is given on the circle, a point is given on the circle. Now, how to find equation of the tangent? Here see, I will take the circle equation as a standard equation, that is x square plus y square is equal to a square. I am taking a point x1 comma y1 on it. You remember, point must be there on the circle. I am taking point as x1 y1. Then in this case, equation of the circle will be s1 is equal to 0 you will get. How can we find it? From equations of the tangents of applications of derivatives. What is the equation of the tangent in application of derivative? Y minus y1 is equal to m into x minus x1. What is m here? Slope of the tangent. So, how do you get slope of the tangent? On differentiating, x square plus y square is equal to a square we can find out. On differentiating, we can find out, here see, we differentiate this, here x square derivative 2x plus y square derivative 2y into dy by dx is equal to a square derivative 0. Then from this, y into dy by dx is equal to minus x. Then dy by dx is equal to minus x upon y. Now, tangent m is equal to m is equal to dy by dx at that point. So, at this point x1 comma y1, if I substitute here, minus x1 by y1 is our slope of the tangent. So, slope we got as minus x1 by y1. Then we will substitute that in our equation of the tangent. What is the equation of the tangent then? Y minus y1 is equal to m. What is m we got? Minus x1 by y1 into x minus x1 we can write. So, it is y1 minus y1 square is equal to minus x1 plus x1 square you can write. So, this can be simplified as x1 plus y1 is equal to x1 square plus y1 square. We got like this. But here, since x1 y1 is there on the circle, here this satisfies equation of the circle. So, if I substitute x and y as x1 y1 here, we will get x1 square plus y1 square is equal to a square. So, this value is a square. So, this is equal to a square. Then what we got now? x1 plus y1 minus a square is equal to 0. See, it is our s1 is equal to 0 for this circle. I told you whenever second degree terms are there, x into x1, y into y1, okay, minus constant term a square is equal to 0. So, in this way, even it is any circle whose center is at minus g comma minus f, the same thing we can find out. So, equation of the tangent drawn at any point on the circle is always equal to s1 is equal to 0. You remember? Okay, this is not only for circle, for all conics, parabola, ellipse, hyperbola, for all these, at any point on the curve, a tangent is drawn, it will be, equation will be always s1 is equal to 0. In circle, our equation is x square plus y square or general equation. In parabola, the equation is different. So, equation changes, but notation is same, that is s1 is equal to 0. Equation of tangent drawn at x1 y1 to any circle s is equal to 0 is s1 is equal to 0. Now, we will go ahead with if a line is given as tangent, how to find point of contact. So, remember here, if a point is given on the circle, then equation of the tangent is s1 is equal to 0. Now, if a line is given as a tangent, that means suppose a circle is there, here a line lx plus my plus n is equal to 0 is given as a tangent, then how to find this point of tangency? That means the point where it touches the circle. To do this, let us take circle as standard equation, that is x square plus y square is equal to a square. So, center is 0 0, radius is a. Now, to find out point of contact, we have a standard result, no? The point of contact, this point of contact is always equal to, minus a square L by n and minus a square m by n. How this will come, I will explain. This is our point of contact, means any line like this touches this circle, you always get this point of contact as this. We can do this by foot of perpendicular. That means from center, if I draw perpendicular to the tangent, okay, why? Because radius perpendicular to tangent, then this point is our point of contact. You can find like this, or else we can go ahead like this for all conics, because this foot of perpendicular is valid only in circles, in the remaining conics it is not valid. So, we will go in general process. What is the general process? We assume that this point of contact as x1 y1 first, this point of contact as x1 y1. Then here, if x1 y1 is the point of contact, from this equation of the tangent at x1 y1 is s1 is equal to 0. That means for this line, by the previous concept, equation of the tangent will be s1 is equal to 0. So, let point of contact, that is point of tangency, as x1 y1. Then equation of the tangent is s1 is equal to 0, is nothing but xx1 plus yy1 minus a square is equal to 0. It is equation of the tangent. But originally what we are asking, point of contact of this line with respect to this circle. That means we already assumed that this is the tangent at this point. So, for this line we have two equations. One is this equation by definition and another is this equation. So, we can say that Lx plus my plus n is equal to 0, and these two equations represent same line. That means if x1 y1 is point of contact, by this s1 is equal to 0 is the equation. But we assumed that it is the point, it is the line, then we are collecting point of contact, no. So, this line has two equations. So, these two must represent same. So, whenever two lines represent same, the ratio of, that is coefficients, ratio of the coefficient must be same. So, x coefficient x1 upon x coefficient L, here y coefficient y1 upon m is equal to constant minus a square upon n. Now, on equating this with this and this with this, x1 is equal to minus a square L by n, minus a square L by n, y1 is equal to minus a square m by n. So, point of contact is, that is point of tangency is okay, minus a square L by n and minus a square m by n. In this way, okay, point of contact we can find. A line Lx plus my plus n is equal to 0 touches this circle, then we can find out. Suppose it is given as our general equation, then same procedure. We take s1 is equal to 0, you will get equation of the circle. Compare that line and this line, then you will get x1 comma y1. Otherwise, you can go ahead by foot of the perpendicular. Otherwise, by taking that as central form and shifting origin to h comma k, this line also to h comma k, we can find out. These are the ways to find out point of contact. See, if the point is there on the circle, then as far as our discussion, we can find out point equation of the tangent. But point is there outside of the circle, then we cannot use this s1 is equal to 0. So, to find out, that means we know already from external point we can always draw two tangents to the circle. These two lengths always will be equal. Suppose this is the point x1 comma y1, then if you want to find out equation of the tangent which is drawn through this, we cannot proceed by this. So, in such cases we write equation of tangent in slope form, that is in terms of m. So, what is that? Here see, if y is equal to mx plus c is a line which is tangent to a circle, is tangent to x square plus y square is equal to a square circle, then we observe what is the value of c. Then that c by replacing over here, we can find equation of the tangent. Here see, any line tangent to the circle, we have radius is equal to distance. So, radius here a is equal to distance from center to the line, here center of the circle is origin. So, 0 0 to this line, distance m into 0 minus 0 plus c by root over of m square plus 1 we can write. Distance from origin to the, this line we are writing. So, on cross multiplying this, we can write and squaring c square is equal to a square into 1 plus m square we can write. So, it is c square value. If I write the c values from this over here, that is y is equal to mx plus or minus c value plus or minus a into under root 1 plus m square. So, a into under root 1 plus m square. This is the equation of the tangent in slope m. We use this to find out equation of the tangent drawn from external point as well as to find out angle between tangents, all cases. So, remember y is equal to mx plus c is tangent to the circle. We are getting c square is equal to a square into 1 plus ms square, and c value plus or minus a under root 1 plus ms square. We are keeping here, we got equation of the tangent completely in slope m. Okay. Now, we will see for some more concepts on this tangents and normals in the next class.